Okay, everyone, thank you for joining us today for a webinar with Dr. Bruce Lanphear and Pesticide Action Network. My name is Jonna Nardone. I'm the Communications Associate at Pesticide Action Network. I will be moderating and facilitating the webinar today. Just a few housekeeping things before we get started. So all the listeners or the attendees, you guys are on mute, and best way to communicate it with us is through the Q&A box. We'll take your questions, your specific questions about the presentation at the end of the web, or after Bruce and also Kristen with us presents. So again, my name's John A. I'm the Communications Associate. I work on campaigns around children's health and pesticides. Our presenter today is Bruce Lanphear. He is an MD and MPH. He is a clinician scientist at the Child and Family Research Institute in British Columbia. He's also a professor in the Faculty of Health Sciences at Simon Fraser University in Vancouver, Canada. His primary research goal is to help quantify and ultimately prevent disease and disability like asthma, learning problems, and ADHD due to exposure to environmental contaminants such as lead, tobacco, and pesticides. He is leading an effort, an online effort to create an atlas of environmental health to increase public understanding of how environmental influences impact human health. He recently narrated and helped create a video titled Little Things Matter. I think he'll share that with us a little bit later today, and we've also circulated that online as well. It's a great little video that talks about how these small doses of exposures to common environmental contaminants like pesticides lead to health and brain development, or how they affect brain development. So after Dr. Lanphear's presentation, we'll turn quickly to our policy and program director at PAN, we've got Kristen Schaefer, that's also with us today. And then we'll turn to your questions. So with that, we'll go ahead and get started. Bruce, you want to pull up your presentation? Another housekeeping thing while Bruce is pulling up his presentation is that we are recording the webinar, and we'll share it with attendees after the webinar is completed.
Okay, should I go ahead?
Yeah, please do.
All right, well, good morning. What I'd like to do this morning is talk about pesticides, but within the broader context of other toxins. And the reason I want to focus on not just pesticides is because it seems to me that it's the pattern of toxicity that we've seen that helps us take action. So when I talk about little things matter, most importantly, of course, I'm talking about children. But as you'll see, it's also about this idea that low-level toxins can be extraordinarily important, even though for a long time they've been dismissed as being too low to be of any consequence. And in particular, I want to focus mostly on brain-based disorders in children, in part because we think the brain is the most sensitive, but also I think because we need to begin to reframe how we prioritize diseases or disabilities. It's one thing, and of course can be quite traumatic, when somebody dies at age 72 or 78. None of us like to see people die. None of us like to see people suffer. And yet, one of the things I've been struck by is that we give so much of our attention and resources to that stage of life, the end of life, and yet this idea that the brain might be adversely impacted, leading to a variety of problems, depression, ADHD, learning disabilities that have lifelong consequences, it seems to me is undervalued. And so I want to focus on brain-based disorders. And while it's not entirely clear that all of these are on the increase, it does appear, for example, that autism is rising dramatically, perhaps ADHD with some questions. Antisocial behaviors like conduct disorder, if anything, appear to be on the decline as blood lead levels have come down. But regardless of this trend, it's clear that if 1 in 6 children are impacted by one or another type of a brain-based disorder, we are in the midst of an epidemic. It is, of course, important to recognize that while I'm going to talk about mostly toxins today, there's a number of factors that can impact brain development, including child sex, nutrition, preterm birth, the built environment, maternal depression, and genetics. It's also important to recognize that many of these are linked. So, for example, if a pregnant woman is actively smoking or exposed to secondhand smoke, the amount of folate she has for her developing child is diminished. Similarly, if you have poor iron status, you're more likely to absorb lead and other metals. And so these things interact, and we really can't entirely separate them. One of the other main concepts I want to get across is that most of the recognized or established toxins were discovered only as a result of an environmental disaster. We'd all like to think that there's somebody out there screening these so that we're not exposed to another toxin when an old one's replaced. But to a large extent, that's not true. Also, there's increasing evidence linking toxins, even at low levels, with disease and disability. And then finally, all of this points ultimately to the need to revise regulations and to reduce exposures. So I'm not going to go through a list of environmental disasters, but certainly Minamata disease is particularly noteworthy. First, it awoke us to the idea that the placenta is not a barrier to toxins. And second, that the developing fetus is exquisitely sensitive. It was, of course, the mother who was ingesting mercury-contaminated fish, but as you can see here, it was the child, the developing child, that was devastated.
Bruce, were you intending to share some slides, because none of us are seeing your presentation right now?
Is that right?
Yeah.
All right, well, let's see.
Yeah, so take a second.
Yes. Here we go. I'm sorry about that. Let me know when you can see it.
Looks like we're on our way. Yes, thank you.
All right.
Great.
Well, I apologize. First lesson of the webinar, right?
Yeah, it's always going to happen.
All right, so these are the brain-based disorders that I talked about, impacting anywhere from a few percent with anxiety, all the way up to about 10% with ADHD. These are some of the different factors that can impact brain development that I talked about. And then these are the three kind of general concepts I want to get across today. First, environmental disasters were how we first discovered these now recognized or established toxins, low-level toxins increasingly being associated with disease and disability, and finally, the need to revise regulations and reduce exposures. This is, of course, the classic photograph of Minamata, congenital Minamata disease that I mentioned. But these disasters are really just the tip of the iceberg. What we're increasingly finding, if we just use organophosphate pesticide poisoning as an example, while there is overt poisoning, in this case about 100 to 300 cases of death from overt organophosphate poisoning, much of the disease is chronic, from chronic low-level exposure or subclinical toxicity. And that's going to be the focus of the talk this morning as well. One of the other things I'd like to share as a general overview is this idea of genes and environment. And oftentimes, I'm sure many of you have read that 70% of autism is genetic, or 70% of ADHD is genetic. Those are both fairly commonly reported figures. And of course, that's great for the scientific enterprise, for encouraging more resources to be invested in genetic research. But it's really not quite that simple. What we understand about most conditions, certainly conditions like autism, ADHD, and depression, as an example, is that these are the result of the interplay of genes and environment. That is, these are complex diseases. And so a more appropriate way to think about these is that complex diseases are 100% genetic and 100% environmental. I'll give you a quick example. This is using prenatal tobacco smoke and genetic susceptibility. And if we focus just for a moment on the one at the bottom of your screen, this is the impact of maternal smoking on low birth weight. And what you can see there is women who are continuously smoking are much more likely to have a child that's low birth weight. We can also identify genes that are associated with detoxifying tobacco, and that in some cases are associated with low birth weight. In this example, it wasn't until you looked at it in relationship to the environmental exposure. And what you ultimately find is it's only the children who are both genetically susceptible and who have the environmental exposure, in this case, tobacco smoke, who are adversely affected. And you can see that over here in the red bar. Now, if that's true, then in a provocative statement, Jeffrey Rose might suggest that if we're interested in prevention, and if we can identify causes or risk factors, then susceptibility ceases to matter. Now, that's not where we're making our investment clearly. Most of our investments are going towards more of a treatment-oriented model as opposed to a prevention-oriented model. But if you're interested in prevention, we really need to focus to a much greater extent on the environment, like environmental toxins. Over 50 years ago in Silent Spring, Rachel Carson wrote, "For the first time in the history of the world, every human being is now subjected to contact with dangerous chemicals from the moment of conception until death." Now, I use this Dow Chemical advertisement as a bit of a spoof. They talk about the human element. What they really don't like to emphasize is that many of the chemicals that they and other chemical industries manufacture and market can be found in all of us, beginning in the first environment, the uterine environment. What I'd like to do now is just take a few minutes and go through part of the video, Little Things Matter, to get across a couple points. The first is about low-level toxicity, and the second is population impact. It's true, not all chemicals are bad, but toxic metals like lead and mercury are found in all of us. So are persistent toxins like PCBs and endocrine disruptors such as bisphenol A and flame retardants. We've been studying the impact of toxins on children for the past 30 years and reached the inescapable conclusion: little things matter. Toxins can have a lifelong impact on children. We've also discovered that extremely low levels of toxins can impact brain development. Let's take a look at the percent of children who are exposed to some of these toxins using a national study in the United States. To keep it simple, we'll use 100 children to represent all children. Mercury is found in 89% of children, primarily from eating large fish contaminated by pollution. Lead is detected in the blood of all children, regardless of race, income, or where they live. Over 80% of children are exposed to organophosphate pesticides, mostly from food. All children are exposed to PCBs, a persistent pollutant that was banned in the 70s but will linger for generations. Bisphenol A, or BPA, is found in 96% of children. PBDEs, a type of flame retardant, are found in 100% of children. But these toxins don't occur in isolation. Children are exposed to many toxins and dozens of untested chemicals all the time. Let's take a look at the body burden of a typical child, one toxin at a time. If each marble represents 1 part per billion of a toxin, this figure represents the body burden of a typical child. 1 part per billion is deceptively small. It is only about 2 tablespoons of sugar in an Olympic-sized swimming pool. But chemicals can be biologically active, even at very low levels. The chemical industry has tried to assure us that concentrations of these toxins are too small to cause harm. but chemicals designed by drug companies to alter behavior, like the prescribed dose of Ritalin, a drug commonly used to treat children with ADHD, is active at levels about the same or even lower than toxins found in the blood. Besides, a lot of studies have shown that some chemicals can be toxic, even at very low levels. As the body burden of PBDEs in pregnant women increases, the intellectual ability of their children decreases. Let's take a closer look. As the level of PBDEs in mother's blood increases from 10 to 100 parts per billion, the IQ scores of their children drop by about 5 points. We see a similar pattern with organophosphate pesticides. As the level of organophosphate pesticides in pregnant women increases from 10 to 75 parts per billion, the IQ scores of their children drop by about 5 points. In the 1960s, hundreds of children died from severe lead poisoning every summer. Since then, much lower levels of exposure have been shown to result in learning deficits and brain disorders like ADHD. In fact, the World Health Organization and other agencies agree there is no safe level of lead exposure. As the level of lead in children's blood increases from 0 to 100 parts per billion, IQ scores drop by about 6 points. In contrast, an increase from 100 to 200 parts per billion results in an IQ drop of 2 more points. An increase from 200 to 300 parts per billion results in an IQ drop of another point. The impact of toxins on the developing brain is permanent. Children who are more heavily exposed to toxins won't reach the same peak cognitive ability as those who have lower exposures. These studies show that there is no safe level of exposure. They also indicate that the way we regulate toxins, which assumes there is a safe level, fails to protect children. The chemical industry argues that the effect of toxins on children is subtle and of little consequence. But that's misleading. Little shifts in children's IQ scores have a big impact on the number of children who are challenged or gifted. Let's go back to our original sample of 100 children and look at a typical distribution of IQ scores. Most of us have IQ scores that fall between 85 and 115 points. Only 2.5% of children have an IQ above 130, which is considered gifted. There are about 6 million children in this group. On the other end of the distribution, another 2.5% of children have an IQ below 70, which is considered challenged. The impact of exposure to a toxin like lead causes a 5-point drop in IQ. This shift results in a 57% increase in the number of children that are challenged, from 6 million to 9.4 million. There is a corresponding decrease in the number of children that are gifted, from 6 million to 2.4 million. Little shifts matter. The impact of exposure to another toxin, like flame retardants, results in a further increase in the number of children who are challenged, from 9.4 million to over 11 million. There is a further decrease in the number of gifted children. Although many. So one of the reasons, I want to go through a list of some of the reasons we focus on brain development and the impact of toxins on the brain. One is that during fetal development, the blood-brain barrier isn't fully formed, and it's more permeable to toxins. In fact, lead exposure in laboratory studies has been shown to disrupt the blood-brain barrier. So it could be that they even magnify the impact of other toxins by having exposures to lead. Rapidly growing cells are often more vulnerable to toxins than slow-growing cells. That's how chemotherapeutic treatment works. We give the patients who have cancer toxic drugs and hope that they primarily kill the fastest growing cells, which is cancer, but of course they also can impact other cells. But in the same way, because the brain is growing so rapidly during fetal development and even into early childhood, it is more susceptible to toxins. Moreover, brain growth occurs over a longer time period than other organs. And then the fetus and the child may lack some of the enzymes that we've evolved with that can detoxify some of the contaminants. And then finally, young children, because they put their hands in their mouths, because they're close to the floor, because pound for pound they ingest more and drink more, they're going to be more heavily exposed to contaminants than older children and adults. So these are a variety of reasons why we're particularly worried about the developing brain. I want to spend a few minutes talking about organophosphate pesticides and use some representative studies. to talk about some of the impacts of organophosphate pesticides. Now, it shouldn't surprise us that organophosphate pesticides are toxic. They were designed to be toxic as part of a war effort. The question really is then one of, at what level are they toxic and what are the impacts? This was an anthropologic study that really raised questions and I think prompted a lot of us to begin to ask more questions about how do we study the impact of pesticides. These children, the Yaqui children, were exposed to pesticides if they were in the valley, a variety of pesticides, a mixture, which is one of the challenges of trying to study the impact of pesticides. It's not only that many of us or most of us are exposed to a variety of toxins, many of us are exposed to a variety of pesticides at the same time. But what Elizabeth Gillette was able to do here was to show differences in the children who lived in the valley who were exposed as opposed to those who lived in the foothills who were unexposed to pesticides. And the results, as you can see with this particular test, were quite dramatic in some children. So I've already alluded to some of this, that exposures to pesticides can occur from a variety of ways. If we take the typical child, we think that dietary exposure is the primary source, but for some children, the exposures might be considerably higher from agricultural applications because of where they live, because of their parents' occupation, and they might bring home some exposures. Other sources can be pesticides that are used in and around the home. If your child attends daycare, they can be exposed, and in some states, it's routinely required that the daycares have pesticide applications on a monthly basis. And then finally, of course, transplacental or fetal exposures. One of the other challenges about measuring the impact of organophosphate pesticide exposures, as well as other non-persistent pesticides, is that the half-life is quite short. And while having a snapshot, a one-time urine specimen, can give you some insight into the kinds of exposures, it's hard to use one urine specimen to look at exposures over, let's say, 9 months of pregnancy. And so that's been one of the limitations that we've all struggled with as we try to measure the impact of exposures on some of these outcomes, like birth weight. Moreover, most of the studies, with the exception of the Columbia University study, rely on measuring the metabolites of the pesticides, not the parent compound. Most of us use urinary DAPs, which breaks down into 3 different types of dimethyls and 3 diethyls. And so, once again, this gives us clues, but it's not a perfect exposure biomarker. This is the study that I mentioned in the video from Chamacos. This is children who were migrant farm worker children. And what they found over this range of exposure is quite a sizable reduction in IQ, probably along the same range as we see with blood lead levels in children and its impact on IQ. 2 other studies were published simultaneously, one from the Columbia University Children's Environmental Health Center and the other from the Mount Sinai Center, and they saw consistent evidence that prenatal exposure to organophosphate pesticides was associated with cognitive deficits. Ginny Rao and her colleagues also followed up these children, and using chlorpyrifos, they were, as I mentioned, the one study that had measures of that parent pesticide, were able to show in about 40 children, 20 with high exposures and 20 with low exposures to chlorpyrifos, that there were alterations in the brain structure that could help explain the impact of chlorpyrifos on intellectual ability of these children. Now, it's pretty hard to really tease all this together and say this is the mechanism. In fact, that's true for most of the toxins we study because they're all systemic toxins. None of these just affect one mechanism or attach to one receptor. They're systemic toxins. But this gives you a pretty good idea that not only are we able to show impacts on learning, but also brain organization. And that's also been done for lead and brain organization and function tobacco and brain organization and function, and to some extent mercury. The other major outcome that's been seen somewhat consistently with prenatal exposure to organophosphate pesticides is the development of ADHD in children, particularly in boys. And that makes sense because boys are about 2.5 times more likely to meet criteria for ADHD. This is, as I mentioned, a brain-based disorder that impacts about 1 out of 10 children. Sometimes we sort of dismiss it because boys will be boys, right? But when you diagnose children with ADHD, that indicates a severity of impairment. This isn't just boys acting like boys. Moreover, about half of the children diagnosed with ADHD have a learning disability, which can have, again, lifelong impacts, including their ability to learn in school, function in society. And we shouldn't be surprised by the association of organophosphate pesticides or many of these other established toxins. We know from laboratory studies that they do disrupt dopamine. Many of them are dopaminergic toxins. And one of the primary hypotheses about the development of ADHD is that it's due to either an imbalance or a deficiency of dopamine, this neurotransmitter in the prefrontal cortex, that part of the brain that makes us most distinctly human. One of the questions that came up was, does OP pesticides cause autism? Of course, as an epidemiologist, we don't like to use the word cause, but there is some evidence that organophosphate pesticides are a risk factor for autism or autism spectrum disorder. And this is one of the more robust studies where in the CHARGE study, Erver, Hertz, Picciotto, and others showed that as you move away from the fields with pesticide application, in particular organophosphate pesticide application, the risk for autism decreases from about 60% down to about 26% and non-significant. So proximity to pesticide application, again, particularly with organophosphate pesticides, was associated with about a 60% increase in the diagnosis or development of autism. Now, when we say that, we're not really saying that that pesticides cause autism. More likely, what we're saying is that pesticides increase certain types of behaviors or certain defects that are associated with the development of autism. Autism is a complex condition, and so it results from the interplay of a variety of different environmental risk factors and genetics, and it's probably the cumulative effect of a variety of risk factors, including organophosphate pesticides, that lead a child to ultimately meet criteria for autism. So if we flip back to IQ for a minute, just to look at some of the population impacts, while we all understandably focus quite a bit on things like preterm birth, those much more obvious clinical conditions, lead, organophosphate pesticides, and mercury play a big role in the number of IQ points lost. In fact, about 23 million IQ points are lost from lead exposure, even after the decline in blood lead levels, and about 16 from organophosphate pesticides. Now, this is a bit of a moving target. Of course, we've seen lead come down a bit. We've seen organophosphate pesticides, at least in adults, decline somewhat over the past decade. But based upon the existing evidence, these are associated with fairly dramatic impacts on intellectual ability in children in the United States. And if we use lead as an example, which I think is relevant here, because what we've seen with lead is an increase in learning problems, IQ deficits, as well as an increase in the rates of ADHD. And we see the same kind of thing for organophosphate pesticides. So it is analogous, if not identical. And what we've seen with lead is that for every $1 we invest to reduce lead exposure in children, as a society, we benefit somewhere between $17 and $220. Now, for those of you that are involved in health, you recognize that the cost-benefit ratio for childhood vaccines, which has long been touted as the single most cost-beneficial public health or medical intervention in developed countries is about 1 to 16. So this is extraordinarily cost beneficial, and we might predict that we would see the same kind of thing with other toxins that have similar effects, like organophosphate pesticides or flame retardants, for example. And yet, for the most part, we tend to ignore these kinds of problems, in large part, I think, simply because we don't know how to privatize the profits. We aren't willing to make these long-term changes that might only, and I say that with quotes, might only benefit the next generation. Now, I've talked mostly about brain development, but it's worthwhile to point out that residential exposure and insecticide use during pregnancy has been associated with childhood leukemia, and that has stood up to systematic reviews. One of the things you might notice if you look at most of the websites and educational material about cancer is that the vast majority, if not all of it, is focused on treatment. And yet we're beginning to recognize for the most common the most common type of cancer in children, leukemia, that there's a number of environmental risk factors, including organophosphate pesticides, air pollution, or proximity to highway traffic as examples. And yet we are largely failing to take steps to protect children from some of these now recognized, if not established, hazards. Another outcome of some interest is low birth weight and diminished gestational age as an indicator of preterm birth. We found in our Cincinnati study, a birth cohort we call the home study, that a 10-fold increase in prenatal exposure to organophosphate pesticides was associated with about 150-gram reduction in birth weight and about a half-week reduction in gestational age. Now, one of the challenges we have as public health researchers, as public health advocates, is that when some clinicians see this, for example, Michael Katz, who used to be the medical director of the March of Dimes, he dismissed it. This was in the Huffington Post. He dismissed it because he said it was clinically insignificant. So I'd like to make 2 points about that. First of all, 150-gram reduction in birth weight is consistent with what we see with women who actively smoke. The second thing I'd like to point out is that there's this ongoing elusive search for the singular risk factor that causes preterm birth or low birth weight. And I think that's a little silly. I think more likely what's happening is that we see that there's a series of more modest risk factors, each of which nudge a woman towards giving birth to a child who's preterm or very low birth weight. So that concentration of risk factors, each of which nudge a woman towards giving birth to a child that's preterm, are probably where the money is. And we certainly haven't given enough thought to really thinking about how do we take on each of these modest risk factors. So one of the key parts of this that I want to bring out is that there's this pattern of toxicity. We've seen it with established toxins like lead and mercury and PCBs. And now we're seeing it with established toxins at low levels, at levels that just a few years ago, perhaps even still today, have been dismissed as being inconsequential because they're too low. And yet, I don't think we can ignore or dismiss them anymore. The pattern is so clear. And it seems to me that this idea that we have to take each chemical or each suspected toxin and act as though we've never seen a chemical that can be toxic before is anti-scientific. That idea of reductionism has value, but at some point we have to step back and say, why aren't we treating chemicals just like we treat drugs? We know they can be beneficial. We also know they can be toxic. Most of you know that we have failed to do adequate toxicity testing. Of the nearly 3,000 high production volume chemicals, 75% lack even the most basic toxicity tests. Of the 140 registered pesticides that EPA considers to be neurotoxic, the majority have not been tested for developmental neurotoxicity. So while we all would like to think that there are laboratories out there that are testing these chemicals before they're put on the market, the reality is that the laboratory is all around us. The mice in those cages are our children. But it doesn't have to be this way. We've seen the same kind of problem before. Yes, it took 5 decades to regulate drugs, but with the thalidomide epidemic, we finally recognized that we could no longer ignore that drugs, really chemicals, could be toxic. The only difference, it seems to me, between drugs, chemicals that are prescribed for treatment, and environmental chemicals that might be toxic, is that at least for drugs, women have a choice. Do I take this drug or not? For most of us, we can't control our exposures. We can try, we can reduce exposures in some cases, but one of the most telling experiences I had was when I was being interviewed by Joel Bakken for his book, Childhood Under Siege. And after going through this litany of different chemicals and some of their impacts, he says, wait a minute, stop. You do this for a living, he said. I said, yes. You have children? Yes. Can you protect your own children? And I said, no. I can keep focused on maybe 5 or 10 chemicals and really understand it. Beyond that, there's just too much. We have to rely on our federal governments to protect us from these chemicals. What can we do? Well, as a rule of thumb, if we didn't evolve with it, avoid it. Now that might be a little simple. We evolved with lead, but we didn't evolve with it at the high concentrations that we now experience following the Industrial Revolution. So if we didn't evolve with it, or we didn't evolve with it at these levels, avoid it unless it's necessary. Of course, if you need an antibiotic, take it. But otherwise, be cautious about just jumping into the bandwagon. We know how to reduce exposures. This was a now classic study that showed if you take children and randomly assign them to an organic diet, the levels of the metabolites go down dramatically. So we have some sense that we can reduce exposures to some extent, at least for this series of pesticides. There's also a variety of other things we can do to avoid exposures to other toxins. I've just mentioned eating fresh, organic, and unpackaged foods. Avoid canned foods. That'll also diminish your exposure to some endocrine disrupting chemicals like bisphenol A. Minimize the use of pesticides around the home. Avoid cosmetics, fingernail polish, and lotions. I've tried that with my 3 daughters and failed mostly. Support bans on smoking in public places and bans on cosmetic pesticides, which we've done in 5 provinces in Canada so far. And finally, support efforts to update chemical management policies and reduce industrial pollutants. And just to point out that that probably in the end is the only ultimate solution. And then I wanted to end with another quote by Rachel Carson. It is not my contention that chemical insecticides must never be used. I do contend that we have put poisonous and biologically potent chemicals indiscriminately into the hands of persons largely or wholly ignorant of their potential for harm. Well, I no longer believe that they're wholly ignorant. I do believe we've set up corporations that are sociopaths. We can't expect them without regulations to control their exposures. And we've seen that over the last 10 years as we failed to bring about regulations to manage environmental chemicals. We could follow suit with the European Union. That isn't a perfect solution, but by putting the burden back on industry, I think we can make great strides. So I'll stop there. Thank you very much.
Thank you very much, Bruce. That was very informative, and I really appreciate you taking the time to kind of unpack some of those more kind of technical concepts of how, you know, pesticides interplay with many other toxins and how they affect our bodies to not be able to handle other things that come up, you know, in genes in the environment. So from here, I will pass it to Kristen, our policy and program director, and tell us a little bit about how we got here into in terms of policy, being in the situation where our government isn't quite protecting our children from things like pesticides. So.
Great. Can you hear me?
Yeah, I think we might be, my screen is stuck on Bruce's presentation. I don't know if everyone else is seeing that. I'm just taking a moment to, Bruce, you want to stop sharing screen?
Yes.
Perfect. Okay, great. Thank you, Janae, and thank you so much, Bruce, for giving a really great overview of this important problem. And I know that folks we want to have time for questions, so I'm going to run through just really quickly some of the key problems that we see with our current pesticide policies, because I think it goes to answering the question that many folks might be having at this moment, which is how did we get to this place where our children are exposed to these chemicals that science is showing is harming their health. Let me just open this up. Great. Janae, can you see that?
Yep, can.
Great. All right, thank you. So I'm going to, again, run through this pretty quickly. I wanted to, so going back in time, our very first national pesticide law was passed in 1910. And the purpose of this law was actually to protect farmers from products being sold that weren't doing what they said they would do, basically from hucksters that were selling ineffective products. So to address this problem, the law established a registration and labeling system. So fast forward to 1947, our current law was passed into law, the FIFRA, the Federal Insecticide, Federal Insecticide, Fungicide, and Rodenticide Act, and it was basically based on the same system of registration and labeling. And to this day, that is the system that we have in place to control our pesticides. And the reason I mention this background is that I think it's important to understand that the entire approach that we use to control pesticides is not developed with the purpose of protecting human health and the environment. So now I want to run through just a handful of the key problems that we see in the current pesticide rules and the registration and labeling system that we have in place. So first off, it's not a quick response system. Basically, it can take years, even decades for, I'm going to mute my video so that folks don't have to look at me. So it can take years or even decades for EPA to respond when new science emerges that shows pesticide is harming human health in ways that hadn't been understood when the chemical was initially registered. It's interesting to note that in Europe, when concerns come up about human health harms, regulators have the authority to take that product off the market until it's proven safe. This is a much more effective approach to protecting public health. The second point here I want to mention is that the current registration process relies almost entirely on science that is provided by the corporation that is seeking to register that product. And these studies often are protected from public view as they're considered confidential business information. Okay, hold on, trying to forward. Sorry, it looks like I'm not able to forward to the next slide. There we go. Another key, really important critique is that the current risk assessment process doesn't adequately look at the many ways that children can be exposed to pesticides and other chemicals in combination with other chemicals, as we just heard from Dr. Lanphear. This is particularly in rural areas. Children have many additional routes of exposure through air, water, in addition to food residue that all children consume, dust in homes. Dr. Lanphear had mentioned farm worker children can also be exposed from pesticide residues that their parents bring back into the home. So many of these are overlooked, basically. And I think the cumulative, we heard just a lot about in the presentation we just heard about the cumulative effects, and they are basically overlooked as well. There was it basically looks at one pesticide at a time, and though the 1996 update to the law requires some assessment of exposure to multiple similar pesticides, this still doesn't reflect a child's real-world exposure to the many chemicals in his or her environment. They also ignore synergistic effects, how pesticides might have different health impacts when they're combined. And they completely overlook the critical importance of the timing of exposure, which we heard about in Dr. Lanphear's presentation. An important example of these limitations is up right now with EPA's revised health risk assessment for chlorpyrifos which was mentioned in the earlier presentation. This revision, this new health assessment was just recently released for public comment. I wanted to note that chlorpyrifos is one of the OP pesticides in that class of pesticides that are known to have these neurodevelopmental impacts. It's one of the most commonly used OPs. It's actually had been banned for use in the home more than 10 years ago. It was back in 2001 because it was recognized back then that exposure to children had neurodevelopmental effects. Specifically, head circumference was reduced if there was exposure during pregnancy. So our scientists are reviewing the assessment, EPA's assessment, the revised risk assessment for chlorpyrifos right now, and they're finding once more that EPA has missed many of the key pathways of exposure, which means that the risk is hugely underestimated. For folks who follow PAN's alerts, I encourage you to stay tuned for a chance to weigh in on this one. The public comment period is open until mid-March. So the final and perhaps the most fundamental flaw in our current system and approach to pesticides is that the current rules do absolutely nothing to encourage the safest form of pest control. So overall, we feel the best way to protect children from the harms of pesticides is to dramatically reduce the volume used nationwide. We use over 1 billion pounds of pesticides every year, this is agricultural pesticides. So shooting for reduction in that overall use would not only limit children's exposure during their most vulnerable years, it would also lower pesticide levels in the bodies of men and women of childbearing age, which is key to protecting future generations. We have several specific key policy recommendations that would start moving us in that direction, and I'll highlight just a couple of them here so we can get into the discussion time. So first, we think it's important that our regulators, EPA, is able to pull agricultural pesticides off the market swiftly when independent science suggests that they're harming children. Again, having criteria that make it really difficult to bring new pesticides onto the market if the science is suggesting that they're going to be kid-harming pesticides. In the shorter term, it's really important to protect children where they spend much of their time, establishing pesticide-free zones around schools, daycare centers, when children are in their most vulnerable years during those developmental stages, as well as neighborhoods and agricultural areas, is an important initial step to protecting children from the harms of pesticides. And increasing investment and support for farmers who are shifting away from reliance on pesticide use. This is a key piece of the equation. It's a systemic shift that we're talking about, and regulating one pesticide at a time isn't going to get us where we need to go. I think I will finish there, Janae, so that we have time for questions with the participants.
Great, thank you, Kristen. So we can probably take about 2 or 3 questions. I see you got a couple rolling in already. We'll check this one that just now came in. Okay, so I had one person kind of comment about exposures in drinking water from groundwater sources, and if any suggestions on dealing with exposure to children and to pesticides through water. I don't know, Bruce, if you could have anything to say on that one.
Yes, I mean, I think one of the first things, particularly in residential areas, that's been shown quite nicely in Ontario, is that when they banned cosmetic pesticide use, they saw pesticides and pesticide residues in surface waters decline quite dramatically. And of course, it's going to also be relevant to farmland. If there's ways to reduce the amount used on farmland, then the runoff would be diminished as well. The runoff from pesticides would be diminished as well. How actually to get those policies implemented, I think, is the more challenging part. But I think we know that there are ways we can reduce the levels in surface waters. Do you want me to go ahead and look at the next one here on the pyrethroids?
Sure, go ahead, jump in that, and I'll pick out another one after you address that one, because we're rolling in.
This is from Susan, and she's asking about now increasingly we're shifting from organophosphate pesticides to pyrethroids, and this is sort of a pretty standard, whether it's been used, moving from DDT and other organochlorine pesticides, which are persistent, to organophosphates. As we use them, we find, whoops, maybe they're toxic. Now we're shifting to pyrethroids, which at least right now we think might be less toxic. There's some evidence suggesting they might be associated with learning problems, behavior problems from the Canadian study, the Canadian Health Measures Survey that Maurice Bouchard has done. We're doing some work in the home study. I think the main point is, and there's some rodent data that suggest it might be associated with ADHD-like behaviors. I think the challenge right now that Susan's question brings up is that we're constantly reacting. We're constantly trying to catch up and find out after these new chemicals, these new pesticides are put on the market, whether they're causing harm. And of course, by default, whether it's this one or that one, at some point, we're basically literally exposing children and then using them as guinea pigs to find out whether these pyrethroid pesticides or others are harmful. So there certainly is suggestion that they might be. Looking at the relative toxicity of OPs versus pyrethroids is challenging, of course, if we can't even get to the point of knowing whether the pyrethroids are. I think what we really need to do is find ways to do the pre-market testing, the preclinical testing, if you will, where we don't use our children or pregnant women to find out whether these are toxic. That's what has to change. Several people are asking about having PowerPoint slides. Yes, of course, I'll share those. And I think John A. can make those available to you. The video, somebody brought up the question about parts of the video. That's available online, and we can make sure you have the link. Let's see.
Yeah, we're looking at the questions here, folks.
Why am I ignoring the IQ reducing effects of fluoride? Well, because I can only do so much. But I do think that question brings up a very important point, and that is, for a long time, perhaps too long, we've ignored the potential neurotoxicity as well as carcinogenicity of fluoride because it has always been considered sort of a victory of dental health and public health. And one of the most important things public health can do is try to understand whether there are real threats with things like fluoride. I think we are seeing a shift, but it's slow, away from too much supplementation, taking it out of water so people can control their fluoride exposures. We've certainly done that in my home. I don't know that I have the final answer, but I'm pretty sure we have too much fluoride exposure right now.
I was going to maybe end on, maybe Kristen can have a word on this one. I believe someone asked about, how do we make policy shifts when we feel like the lobby interests are so strong? And I thought maybe you could end us on a positive note there, Kristen. Well, any thoughts?
I'm not sure
you've been in this. Kristen has been working on these issues for a long time.
Okay.
Go ahead.
Oh no, go ahead.
Well, I can start, and if you want to add in. So it's a very good question, and clearly there is tremendous investment in the status quo, and the folks that from on the pesticide issue particularly, we are have learned more and more and have seen more and more funding going in from what we call the big six pesticide companies that benefit from the current system. So the good news is that there are, as the health impacts have gotten clearer and clearer and more in the public conversation, there are more and more groups that are, including health professionals like Dr. Lanphear, that are speaking up about the impacts of these chemicals on children's health. There are also groups organizing at the local level, at the state level, and pushing through improvements there that can move us in the right direction in the federal level as well. And one of the things I would point to is we have on our Kids Health Campaign page, which I think, Joanna, you're going to share those resources at the end, a Healthy Kids Toolkit that has ways that individuals can engage both at the individual household level, but also in ways that in your community, and how you can engage to help with policy change and link up with organizations that are moving this work forward. And honestly, we're really excited about the momentum, and it is an uphill climb, and there's a lot of vested interest. But when folks like Dr. Lanphear, Dr. Landrigan, who folks may know, are speaking out and speaking up about the need for change, it really helps to build the momentum and shift the public conversation and create the public will that we need to make those policy changes.
And Dr. Lanphear, did you want to comment on that on policy changes as well?
Well, I'll start out maybe by what I think of as the reality check, and that is what I see happening in the United States right now is that there's so much power in corporations that they've essentially become majority shareholders in our country. And what that means is, whether it's healthcare reform, chemical management reform, is that it's going to take 70 to 80% or more of the public to get behind things like this chemical management plan, to make sure that it gets past the lobbying efforts of these big industries. Having said that, if you look at what's happening with younger people in their 20s, 30s, they're getting it. They want labeling for GMOs. They want to protect their kids from pesticides. So maybe put it another way, change will happen, but maybe we just have to let the old guys die.
It's a different take on things. Thanks, Bruce. Okay, well, I think we're out of time. I was just going to share one more resource with everyone. So I believe I'm sharing the screen about what you can do. Is that what you guys see? Yep. Okay, great. So we're just going to leave you guys on one note. So one thing you can do is we do have an action or a petition to the governor in the state of California. All of you guys are welcome to sign. We have an ongoing campaign specifically around the organophosphate that was mentioned in the presentation of chlorpyrifos, of really trying to get it out of agricultural use. So there's an action here that you would feel free to sign. Also, feel free to download our Healthy Kids Toolkit that Kristen mentioned. You can find that at our campaign page around pesticides and children's health. It's called at our website, panda.org/kids. And please do join us. We share wonderful resources like this and the Little Things Matter power presentation that Dr. Lanphear shared with us during earlier. So we share lots of great resources. Our Ground Truth blog, where we're kind of digesting a lot of the current policy and science around health and the environment and pesticides. So please join us on Twitter and Facebook there as well. And I think we'll wrap it up there. And do look in your email inbox for some follow-up to the webinar today. And we appreciate everyone joining us and sharing their questions. So again, thank you to Kristen, and thank you to Dr. Lanphear for that great presentation.
Thanks, everyone.
Thank you. Johnny, can I go ahead and answer some of these questions in text?
Sure, yeah, if you'd like to, yeah.
I'll try. I don't know how long I can last, but I'll try.
Yeah, exactly.
Okay.